Let's talk about direct variation first. Just reviewing. Anybody? Anybody talk about direct variation?
Describe the simple relationship between two variables.
There we go. So yeah, so when x value, for example, when x value goes up, what happens to the y value in direct variation? Direct variation, it also goes up. Yeah. And we write this relationship with what? Y equals kx. What is k? It's a constant. It's fixed number. Okay, there's a fixed rate that is called constant. And x is the variable that changes, right? And y is changing depending on what x is. So we call x as independent variable. Then y is depending on x, right? So it becomes dependent variable. Okay, and k is a constant. We talked about Gulliver's thumb size and neck size. Remember that? Okay, now let's think about indirect variation, or we call that inverse variation. Inverse variation, it's inverse, reciprocal, right? So y is equal to, how do you write this inverse variation? K over x, right? So k is still constant, which means it's fixed number, it's not changing. Okay, constant. And as you can see, y changes depending on x. So x is independent variable and y is dependent variable. And what's the relationship there? If x increases, what happened to the y? Y was decreased. For example, let's say k is 1 for one example. Okay, if k is 1, we have y is equal to 1 over x. If x is 2, y is 1 over 2. If x is 10, y is 1 over 10, right? So you can see that x is going up. For y, look at that. 1/2 is bigger or 1/10 is bigger? Yeah, think about one whole pizza. If you get 1/2 of it, is it bigger, or you get only 1 out of 10 pieces bigger? 1/2 is so much bigger, right? So the number, well, here the number goes up, but the number goes down here. So that's indirect or inverse variation. Okay. We also learned how to combine them together or join them together. When you have joint variation, you can just multiply them together, right? For example, y is equal to k, x, and another variable. So x and z are variables. K is again constant, right? That's joint. You just multiply the variables, joint variables. Okay? And if you have a compound or combined variation, we have, whatever it's asking you. Sometimes it's gonna ask you to find y when x is directly varies with y, and maybe something like z squared inversely varies with y. Then you can put that x squared and the z squared. Does that make sense? You're gonna solve some problems like this, and that homework is due Wednesday. Okay? And quiz 5 includes section 1. You don't have 2, right? Section 1, 3, 4. Section 1, 3, 4. Yeah, just section 1, 3, and 4 will be included in quiz 5. They are due Wednesday, so you need to work on that today or tomorrow. And 6.5 is what we're gonna work today, okay? So that will be due on Friday. I emailed you about that too, so we're gonna get that. Okay, so we are moving on to inequality, linear inequality. before we talk about inequality, let me talk about equality first. What does equality mean? We all know that, right? Equality, it's equation. So this side, this side and that side are equal. That's equality. But inequality means they are not equal anymore. So think about the balance beam. One side is bigger than the other one, heavier than the other one. That's inequality, going the other way around, right? That's inequality. So when it is not just equal, we're talking about inequality. How about linear? What does linear mean? What does linear mean? Linear. Take off AR. What do you see? Line. It's about line. So when you have a straight line, that is linear. So it's a direct variation. Okay. So we're talking about when you have straight line on the graph. Can you imagine that two-dimensional grid paper? You can draw any line. If it's above y value, it's greater. If it's below, it's less. Okay? So we're talking about that. So we can use these symbols of inequality. A is greater or less than? Less than. Take a look at A. It's less than. So you can open your big to a bigger value, right? So we know that B is greater or A is less than A. How about this one? What's the difference between this and that? You add equal to it. So this is called A is less than or equal to B, right? And this one, A is greater than B. This one, A is greater than or equal to B. We all know that, right? Okay. Knowing that, we know inequality consists of two expressions joined by an inequality symbol. Either greater than or equal to, less than, greater than, or less than equal to, or greater than or equal to. So these are some examples of inequality. It doesn't have to be just numbers, you can add any variables there too. Okay? Okay. So if we have any variable, you need to solve for that. Okay, so for example, if you have x value that is greater than 2, you need to use the open circle because 2 is not included. So it's empty. 2 is not included. So for 2 parts, you need to open that. But look at this x. X is greater than 2. So you are looking at the numbers that is bigger than 2, greater than 2 on this side, right? So starting from 2, but it's not included. So open that up. We move to the right-hand side of it. Does it make sense? Then take a look at this one. X is less than 5. We look at numbers that are less than 5. So on the left-hand side of 5, is 5 included? It's not, right? So we need to open that circle. Make sense? What if we include that value? For example, x is greater than or equal to 3. We know that x is going to be greater than 3, so all the values on the right-hand side of 3. But we also include that 3, so it's going to be shaded as well. So it's called closed. Make sense? The same for this one, x is less than or equal to 6. So we look at numbers that are less than 6 on the left-hand side. So we also include 6 there. Okay? So let me ask you one question. Using this, I will go backwards. You need to find what inequality I'm talking about, okay? So if I have a number line like this, let's say 3, and I'm talking about this part here. What inequality am I talking about? Let's say this is x. So x is what? Greater than 3. Make sense? What if I have value like this? -2. What inequality am I talking about here? If this is y, my y is Exactly, it's on the left hand side. It's gonna be less than, but we are including negative 2 too. So less than or equal to negative 2, right? You can do that. Can I challenge you guys a little bit more? What if I combine these things together? For example, if I have a number like this, let's say this is x, in between these two values, and that is negative 3 and that's 1. What x value am I talking about here?
X is greater than -3, but less than and equal to -4.
There we go. Did you hear what Kristen is saying? X should be greater than negative 3. So x is greater than negative 3. But it's also less than or equal to, because it's close, 1. Right? We're talking about this way. Let me challenge you a little bit more. What if we have a number line like this? Negative 3 and 1. And we go this side. And we go this side. What numbers am I talking about if this is an x? So we cannot have and here, right? Because a number, whatever number I'm choosing, is either here or there. It cannot be here and there at the same time. One number can be on both sides, right? It can't. So x can be here or there. Let's look at this part first. X is less than or greater than? Less than negative 3. It's included, so less than or equal to negative 3. Or your x should be greater than or less than. Greater than, because it's on the right hand side, right? Greater than 1. It's not included, it's open. So we will put equal there. Make sense? Very, very good. Okay, so yeah, once you know that, you can, go back and forth. If you are given this one, you can draw that on the number line. If you are given the number line, you can go the other way around too. Okay, so let's do some practice. Can you graph the solution set of 3 is less than x or x is greater than 3? Read from x. Look at the x. Is x greater or less? X is greater than 3. So on your number line, draw that on your paper. Your number should be greater than 3. So do it now. So easy, right? And this one too. Graph the solution set of x is, look at x. X is less than or equal to 1, right? So draw these two. Show me your thumb if you got it. Okay. Did you get this one? Yeah, x is less than 1, so start from 1. And x is smaller, less, so on the left hand side. And since it's included, you need to shade it. It's closed. How about this one? Left hand side or right hand side of 3? Left or right? Right, because x is greater, right? It doesn't matter which one you write it first. But since x is greater than 3, you need to shade the right hand side. But that circle in 3 has to be open, right? Because it's not included. Does it make sense? Okay. How about this one? Can you solve this one? Ooh, this is not x anymore. It's negative x. So our number line should be x. So try that. So you need to solve the inequality. Negative x is greater than 3. We have to solve for x, not negative x, right? what can we do? Like multiplying -1, right? So when you're multiplying -1, what happens to negative x? Becomes x. Then you're gonna flip it, right? Because it's the other way around. Very good. How about 3 times -1? -3. So x is less than -3. So your number line, this number line is for x, not for negative x. So we know -3 and all the values that is less than -3 on the left hand side. And -3 is open or closed? Open. Excellent. So very good. How about this one? Solve the inequality 3x minus 5 is greater than 7. And I will ask maybe a couple of you come to the board and solve for it. Okay? Anybody here, by the way? Daisy? Yes, yes. And Avery. Okay. Grab a marker here. Avery, you can work on that board, and JC, you can come to this board. Thank you, guys. -5 is greater than 7. Write a little bit bigger so we can see it better. Easy. Thank you. Yeah, practice you're teaching the elementary school kids. So we will pretend that we are 4th grade. We're 4th graders. 3x minus 5 is greater than 7. Yeah, I didn't teach this yet, so you can struggle it, okay? What kind of a teacher is asking the students to do that before teach? Oh, that's called flip the class. You guys started first. Yeah. So you can see that you can struggle, and think about your students too. They can struggle too, right? But I always believe that when you're struggling, you can learn that better. I'm getting there. let her finish it, but thank you, Jason. So how do you feel, Avery? How do you feel when you're solving the problem without being taught?
I feel like I was good up until there.
Right? Some parts you're good at it and you're confident, and do you feel more motivated to learn them? Because there are some parts that you are struggling with.
Yeah.
Yeah, right?
Yeah.
So yeah, I really like the way the students are working first. So if you maybe I can share the article too. We are used to teaching model of what is it? You all, and you. So teacher teach first, then we work as whole class together. Then you guys do your homework. That's just very typical way. But now we are changing this method, teaching method a little bit differently. So you solve that first, and you all work together, and the teacher summarizes it. That's a little bit more effective, they say, according to the research. So we can try that way too. So as you can see, you know some of the concept what's going on there, but some part you can get struggle. It's okay because that's where you can learn from. Okay, so sorry I didn't bring my glasses, so I cannot read it really well. I will just resolve that, okay? Okay, so what, either Avery or JC, what did you do first?
I added 5 and then I put it over and then I said,
Avery, did you do that?
Yep.
First too? How about you guys? Yeah, I agree, because we are solving for x, right? But since 3x is one term, x term, and that's a constant term, we can take that away. In order to do that, we can add 5 on both sides. When you're adding same number, does the inequality change? No, it doesn't. Think about the balance beam. So this is heavier than this. I'm adding exactly same amount. It's still the same, right? It's not changing, right? So we know when you're adding some amount, exactly same amount, the inequality doesn't change. So we have 3x here, and 7 plus 5 is 12. Now what did you do? Oh, why? Exactly, because we are solving for x, not 3x, right? Please, you got the same thing?
Yeah.
Yeah, awesome. So when you're dividing by same number, positive number, it doesn't change either, right? The balance beam doesn't change. So it's gonna be x, and 12 divided by 3, 4. So x is, can anybody read this for me? X is greater than 4. Excellent. So this is our x in the number line, and we have 4 here. And we look at left hand side of 4 or right hand side of 4? So this is greater, right? So greater means right hand side of 4. We include 4 or open it? We open it, but it's not included, right? So it's open. Is that what you got, guys? Yeah. Awesome. Very, very good. So no problem, right? Okay. That's great. Thank you so much. Okay. Yeah, that's about it. How about this one? Solve the inequality x minus 1 is less than 3, where x is an integer. Previously, we had x as a real number. So we included all the numbers in the number line, right? And now it says where x is an integer. It's limiting the numbers. You can solve it similar way. You need to limit the x as integer. X is an integer. Do you guys remember this symbol? This symbol is for element and the set, right? Okay, so x is an integer. Okay. All right. So let's take a look at this together. What would you do first to solve this? Just like before, you can add 1. So this is gone, and you still have x there. How about the right hand side? Less than 4. So we know that our x in the number line, any number that is less than 4, so left or right? Left. So any number here. But it says x should be an integer, so we're not adding all of that. So instead of that, I need to undo that. We are looking at only integers. What are the integers in this side, on this side?
Any number after 0.
Integers are whole numbers and negative of the whole numbers. 0 and negative of that. Negative 1, negative 2, negative 3, and so on and so on. So we are not looking at any numbers here. We are not looking at any numbers in between these. So we are looking at only 3, 2, 1, 0, negative 1, negative 2, negative 3, and so on. Does it make sense? So we are not looking at any number in between. Compare that with 4 on this side. We are still using exactly same inequality. X is less than 4. This is also x is less than 4, and this is also less than 4. What's the big difference here? Why do we draw that differently because the x here should be only integers. So we are not looking at any number in between like 2.4. It's not an integer. We're not looking at negative 1.995. We're not looking at that. So we are looking at only integers. So you are only shading that integers here. So when we have real number, we need to include all the numbers on that side. You see the difference? Make sense? Okay. So let's practice one more thing. What if you have 2x minus 1 is less than 4 and 5? Okay? And x should be, x is a whole number. Can you solve this? So when you're answering that, 1, list your answer. Okay? And 2, use the number line. So this means that I'm talking about use the segmentation in the raster form. So some of the concepts like this, raster form and the set, you have learned this while I was gone. So I'm just checking whether you learned it well or not. Show me your thumb if you got it. Okay? If you need help, please put your thumb down. If it's so, you can just make it, sideways. Good. Okay. So let's solve this together. Help me out. X minus 1 is less than 5. What's your first step? You're going to add 1. Love it. So you have 2x on the right hand side, 6. And then divided by 2 on both sides. Equality doesn't change. X is less than 3. X is less than 3. Now, let's think about number line first. So my x, this is my x, and I see 3 is here. X is less than, so left or right? Left. We are looking at this side, but our x should be a whole number. So which one are we talking about? Only 2, 1, and 0. Those are only the whole numbers, right? So we are shading only 0, 1, 2. Got it? Excellent job. So to make a set as a rotation raster form, we can just put 0, 1, 2. Of course, 3 is not included. You see that? Okay, very, very good. So we can take a look at, what's the number set there. Then you can go ahead. Okay? Are we good? How about compound inequality? We are combining 2 or more inequalities together. For example, x is greater than negative 3 and less than or equal to 2. We already have talked about this at the beginning, right? So on your paper, I want you to graph these two. One with the same inequality. Your number is an integer. It should be different from when your number is a real number. So can you draw 2 graphs that indicate 1 if x is an integer, 2 if x is a real number? Okay. Show me your thumb if you got it. And this time, can I ask Kelsey and Gavin into the board? Kelsey, do you want to work on the real number?
Sure.
Okay. And Gavin, can you work with the integers? Okay. Take the markers from up here. And this time, when you are working on your problem, I want you to explain what you're doing. Okay? So, who's gonna go first? Who has integers? Okay, you go first. Okay, explain that to us, okay? Okay. Yours is integers? Okay. No, I don't think so. I think it's a really good start. So you have open circle for -3 and close the circle on 2, right? Very good. Keep going. Yeah. So which one did you include there? Which ones are included in your graph? Do you agree, guys? Yeah, very good. So because I'm sorry, I cannot see very well. That's why I was like, okay. So thank you. So in Avery's work, I'm sorry, Gavin's work, you can see that 2 is included, right? 1 is included, 0 is included, -1 is included, and -2 is included, but not -3. So if you use the roster from there, you're gonna have what? -2, -1, 0, 1, and 2. Only that, because your x has to be integers, right? Okay, very good. Thank you so much.
So I started mine, I wrote my equation, this is my graph. So this one, that was constant, that's included in one.
Well, can you read that equation, inequality? X is greater than -3 or less than -3? Look at that x and -3 only.
Oh, greater.
X is greater, right?
Okay.
Yes. Yeah, read always in terms of x. Your x is greater than 3, but less than or
Greater than, or less than or equal to.
less than or equal to 2. Excellent. So talking about which part? -3 and 2. So let me just copy it, Kelsey's. So you can combine them together, right? So you have your x is greater than 3 and less than 2, less than or equal to 2. So you're talking about parts in between -3 and 2. And you have -3 open and 2 closed. So this is what you're talking about, right? Very good. Can we write this in the roster form? Like what?
It would be everything between -2, 1, -1, 0, and then everything in between.
Everything in between. So So it's not easy to write. I mean, you cannot actually write that as a raster form because we're talking about all the numbers here. So negative 2.999999999999992, 1.9999999. I don't know what's the biggest number because it goes infinitely, right? So any number there, we cannot write it as raster form, but we cannot write that as descriptive. So x is between negative 3 and 2, and x is a real number. You can just write it this way, okay? So very good. So when you're drawing the graph, they are totally different, even if we are using exactly same inequality, right? Okay, so you always need to take a look at whether the x is integer or real number or the whole number or what kind of number it is, okay? All right, very good. Okay, compounding inequality, a little bit more complicated one. So what would you do first?
Check the next one. So you have to,
Multiply by 2.
Yeah. If you multiply 2 first, you can get rid of this, so it gets easier, right? And then you can subtract 3, right? So yeah, go for that. Shane. Ah, sorry. Very bad girl. Okay, can you work on that and show us how you are solving that? Compare Shane's work with yours, okay? Shane, pretend we are 5th graders, okay?
So I guess what we would start with is we take our 2 off the bottom here and we multiply by 2. So you're gonna multiply both sides of it. So negative 4 times 2 is gonna give you a negative 8, which is less than x plus 3. The x plus 3 is less than or equal to 10. And then we're gonna subtract 3 from both sides. So then we'll have a negative 11 is less than x. And x is less than or equal to 7.
Did you follow? Okay, very good. Can you draw that on the graph? If it doesn't say anything about the numbers, then it's real number, okay? Very good. So it's gonna be between negative 11 and 7. Negative 11 is open and 7 is closed, right? Okay, excellent. Any question for that? No. Good. Before we move on to the next example, let me give you one more. What if we are given a problem like, what is this? Is it one? A problem like this. Let's solve this together. What's the first step? Again, multiply by 2 because this whole thing is divided by 2. When you are multiplying the same number on everything, the inequality doesn't change, right? So we have negative 8 and we have negative x plus 3 and 10. Now what? Subtract 3 on both sides, on every side. Negative 11, we have negative x and 7, right? So from here, what do? I didn't solve for x, but I have negative x there. Exactly, exactly. Avery, what do we do? We need to solve for x, but we have negative x there. So we have 2. This is negative 1 times x. So to change that to x, what can we do? If we multiply this by negative 1, yeah, then negative 1 times negative 1 becomes positive 1, right? So we're going to multiply this whole thing by negative 1. When you're multiplying by negative number, what happens to the inequality? You need to flip them, right? So you need to go the other way around. So negative 1 times negative 11, positive 11, negative x times negative 1, x, 7, negative 7, right? So we start from negative 7 because that's the smallest number. Biggest number is 11. So on your number line, you can put negative 7 as the smallest number, and 11 is your biggest number, right? And your x should be any number in between. Okay? So when you have x value, the coefficient of x, which means whatever multiplied by x is negative, you can divide by the same number, so multiply by reciprocal of that. But when you're doing that, you need to flip the inequality sign. Okay? That's what I wanted to talk about. Okay. So let's go back to our problem here. We already got that. And I want to give you one example with a real world situation. So a student must, oh, this is interesting problem and I love this one and I saw this almost in every textbook. Okay, so you need to know what's going on there and I want you guys to know how to solve it. A student must have an average. Suppose this is you. You must have an average on 5 tests that is greater than or equal to 80%, but less than 90% to receive a final grade of B. Let's suppose you want to get B on your final grade. Your grades on the first 4 tests were 98%. It's really good. The second one didn't do very well, 76%. The third one, good, 86 and 92. What range of grades on the 5th test would give him a B in the course? How can you solve this? There is a lot of things going on. So you need to know how to find the average first. You need to set up an inequality there, and then you're gonna solve for that. So, shall we look at that together or do you wanna struggle first? Okay, you wanna struggle first, right? Okay, so I will let you struggle a little bit. Just a little bit. And persevere in solving that problem, okay? Show me your thumb if you got that. If you're struggling so much, put your thumb down. F so sideways. A problem like this will be on the final exam, okay? If you want to make a star on it, you can go ahead and do it. Got it? Okay, so let's look at this together then. We're almost out of time. Okay, a student must have an average on 5 tests between 80% but less than. So we know whatever of our average should be what did you say? Greater than or equal to 80%, right? And less than, so we don't include 90. Is it okay so far? And average should be sum of all the exams divided by how many tests, right? How many tests are there total? So far there are 4, but we're gonna have 5 of them total, right? So divided by 5 should be greater than or equal to 80 and less than 90. Are we good? Okay, then we are done actually because we know how to find the sum. How do we find the sum of 5 exams in test? The first one is 98. Second one is 76. Third one 86. Fourth one 92. And the fifth one, we don't know. That's what we are looking for. So we can put that as x. So my x is defined as the fifth test score. Right? So divided by 5, that is the average of 5 tests. That is between 80 and 90. Where 80 is included and 90 is not. Then we are done. Hey JC, can you help me? What is 98 plus 76 plus 86 plus 92? Anybody? Any of you got that yet? Hey JC? That's 352? 352? Okay. 352 plus x, right? So sum of 98, 76, 86, 92 is 352. And you have the fifth exam test divided by 5 is between that. Now it's simple. We know how to solve this, right? What do I do next? Multiply by 5. Multiply this whole thing by 5. And 5. When you're multiplying the positive number, then you come to the change. So this is gone, and we have 5 times 80, 400, and you have 352 plus x. 90 times 5, 450, and subtract 355 on every side. 352, 352, then you have x. What's 352 subtracted from 400? 48. How about you? 98. So if you get any score greater than or equal to 48 but less than 98, you will get a B. Okay? So that's the range. Make sense?